Okay, I'm back, and now we're going to go to part C of part 1 on interference. And now this one is going to be two-slit interference. Now you're going to need to go to a computer simulation for this one. There's two of them that you can use. So one of them is the PhET simulation, interference and diffraction. And then the other one I found is entitled Ripple Tank Simulation, and it's located at Falstad, falstad.com /ripple /. And so with either one of these two simulations, the point is to make two-slit interference. So if you have just one slit, then what it's going to do is it's going to, let's say that the slit is here. The slit is here. It's going, when the waves up here are going through the slit, it's going to make a series of ever expanding ripples. If you've got two slits, then it's going to make two sets of ripples that are going to interfere with each other constructively and destructively. So I want you to simulate that with those computer simulations and to understand what causes the constructive and the destructive interference of it. So you can use your notes, has a nice picture of it, and then also you can go to Google and find an article on two-slit interference as well. Okay, then let's go to part 2 of the lab, which is entitled diffraction. So diffraction is what happens whenever a wave, it could be light or it could be water, goes around an obstacle. So there are two of them that I would like for you to do if you can, and if you can't do it, you can at least look it up on the internet and find out how they work. So the first one is edge diffraction, in which you're going to take a laser pointer, and you can get one of these at Walmart for around $5, and you're going to shine the laser at the edge of a razor blade and then observe the diffraction fringes that form. So I would encourage you first to go to the internet and then find razor blade diffraction fringes, and then go to images so that you know what you're looking for. And then try to do it with your laser pointer. So I'm not going to tell you you have to go out and buy a laser pointer, but you could do this experiment if you go out and buy one. Then the slit diffraction is going to be what happens whenever a wave goes through a slit. It's going to spread out, so that's diffraction, and then it will also interfere constructively and destructively as it spreads out. And one way of demonstrating that is you can make your own slits with a couple of pencils. So you're going to take one pencil and then wrap a single piece of Scotch tape, so it's got a layer, one layer thick, around the end of the pencil. That way, when you take two pencils and you put them together, there will be a very, very thin slit between the two pencils, less than a millimeter. You need a slit very, very thin. Then you're going to take your laser pointer and shine it through the slit, and then as you are doing that, you're going to be looking at the slit, and what you should observe is kind of like beads on a string that are going to be horizontal. So you'll see beads on a string that are going to be horizontal across the pencils. Where you see a bead is going to be destructive interference, and where you don't see a bead is going to be constructive interference. So I'd like for you to try that one with your laser pointer. And then also what you could do is you could very carefully open the slit or close it and then see what that does to the location of the beads. Now for part 3 of the lab, you're going to need polarizers. So it says look at light through a polarizer. And then so you can get polarizing sunglasses for this. You can get a very cheap pair of polarizing sunglasses at Walmart in the sporting goods section, and you can get them for about $4. And so if you get 2 of those, then you got a pair of sunglasses and you can do the experiment. I'm not going to make you have to buy the sunglasses if you don't want to, but if you have a pair of polarizing sunglasses, this is what you can do with them. So I'm going to get out some Polaroids here to show you what's going to happen. So notice that you can see me through a single polarizer, and you can also see me through this polarizer. Okay, but if I put the 2 polarizers together like this, so here's one, here's the other one, and I put them together, you can still see me. Okay, but now what I'm going to do is I'm going to take this one and I'm going to start to rotate it, and it's like magic. So when the 2 polarizers are perpendicular to each other, no light gets through them. So you can see how this might be useful in a window to cut the amount of light that is coming through a window. So what you can do is if you get 2 pairs of polarizing sunglasses, it should work. So you take the 2 and take one of them and hold them the way that you would normally wear the sunglasses, and then with the other one put it perpendicular to it, and it should get pretty dark through it. Okay, another thing I want you to do with your polarizing sunglasses is go outside and look at some glare that is coming off a windshield of a car, and look at it through your polarizing sunglasses. Okay, then take your polarizing sunglasses and turn them perpendicular, and then observe what happens to that glare. Or you can wear the sunglasses and then turn your head sideways, whichever way that you feel comfortable doing that. But this is going to be polarization. I would like for you to be able to explain what polarization is and how does a Polaroid work? How do those polarizing sunglasses work? So it's in your notes. Okay, so now if you'll go down to your post-lab questions, you have some questions there that you need to do. So do as many of these experiments as you can, write some comments about each of the experiments, and then email it to me. So we're finished with this lab, and so until next time,